Hello, calculus students. We are going to be continuing our discussion on assignment 2.1, specifically looking at number 28, looking at 28 and 29. We're going to review what we did in number 28 and then see how that applies to number 29. So for 28, we're looking at the limit as x approaches 0 of x plus the sine of x all over x. Now, the first thing we're going to do is we're going to rewrite this as the limit as x approaches 0 of x over x plus the sine of x over x. This is a legal move. All we've done is take this fraction and we've taken the numerators and we've split those up. So, now we have, and we did this for a couple of reasons. One, because x over x is really easy. X over x is equal to 1. Anything divided by itself is simply 1. And then we have, and using our addition rule of limits, we can also say that this is going to be the limit as x approaches, so it's the limit as x approaches 0 of 1 plus the limit as x approaches 0 of the sine of x over x. Now there are a couple reasons this is really nice. The first one is the limit as x approaches 0 of 1 of any constant is that constant value. So we can say that this part is equal to 1. Hey, that's nice. Good. Now the other one, the limit as x approaches 0 of sine of x over x. We have proven, if we look earlier in this section, we did this in class, that the limit of the sine of x over x as x approaches 0 is equal to 1. So 1 plus 1, our final answer is 2. So we'd say the limit, our final answer is, we'd say the limit as x approaches 0 of x plus sine of x over x is equal to 2. Let's see how we can take this idea and apply it to number 29. Now, I did see some people's comments on this already, and some people were on the right track. Some people need a little bit more of a nudge in the right direction. So we're looking at number 29. We're taking the limit as x approaches 0 of sine squared of x over x. Some people's thoughts were to take the square root of both of this, but we can't, because if we take the square root, we're actually changing it. We would need to take the square root of both sides of an equation, but we don't have an equation. We just have an expression. We don't actually have an equation to deal with it yet. So with number 29 here, what I'm going to do is I'm going to break this up a little bit. I'm going to rewrite this as, I'm going to call this the limit as x approaches 0 of sine of x times sine of x all over x. So sine of x times sine of x over x. This is the same as sine squared of x. And then our denominator didn't change. But the important thing is we can rewrite this as the sine of x. Oops, and I need to be a little bit more careful about my notation here. We can rewrite this as the limit as x approaches 0 of the sine of x over x times the sine of x. Good. So now let's see, well, what happens as the sine of x over x approaches 0? Well, we know this, and again, this is being a little bit sloppy. I should be a touch more formal in this. We're taking the limit as x approaches 0 of the sine of x over x times the limit as x approaches 0 of the sine of x. Again, we've already done the work for this. We already know, we already did this in class, it's already in your textbook. The limit as x approaches 0 of the sine of x over x, this is equal to 1. So that's the easy part. Now we want to find the limit as x approaches 0 of the sine of x. Well, there are a couple ways we can go about doing this. If you remember your trigonometry well, this would be helpful. If you, or if you just learned this part in trigonometry, that'd also be very helpful. But in case you didn't, in case you need some help remembering, go ahead and punch this into your graphing calculator. Because it's 0, it actually does not matter whether you are in radian or degree mode. The sine of 0 in both of these will end up being the same thing. The sine of 0 is going to be 0. So 1 times 0, well, what is 1 times 0? It is equal to 0. So we would say for our final answer, the limit as x approaches 0 of the sine squared of x over x is equal to 0. Those are all the questions that have shown up since our last visit. This will get posted both on the Moodle page and on my YouTube site, which I will put a link to as well. So have a great day, and I will see you in class and at the Moodle orientation tomorrow.